Okay, so we have the cylinder, and we're first looking at surface area, right? So surface area would be 2 pi r squared plus pi d h, right? If you look on your notes, that would be your surface area formula. So what's radius? 5. What is diameter? What is it? 10. We take 5 and multiply it by 2 to get diameter, right? Because this is radius. Diameter would go all the way through. So 5 times 2 is 10. And the height, even though it's laying this way instead of up and down, is the distance between the two circles. So what's the height? 11. Now, I'm going to tell you another story real quick before I continue. And if I told you this story, just tell me and I'll stop. Because sometimes I repeat myself.
Is it less of cylinders 11 miles?
Yeah. So what could be 11 miles that look like that?
One of those, Chesapeake Bay, I think. It was the underground, tunnel thing.
Tunnels? Yep. Or piping for like oil. Have you heard of the Canadian pipeline that they're trying to install? All of that would be circles, correct? Now, I had a student who was a pain in the patootie because I taught high school for many years, and they always gave me the classes where I co-taught with the resource teachers. And I not only had him for Algebra 2, and I'd have him for 2 periods a day for a whole year, and then I had him for geometry for 2 periods a day for a whole year. Yes. So, because they needed more practice, and since it was the resource students, that's why it was 2 periods. So, years later, after he graduated, all of a sudden it's after school, I'm getting ready to leave, and he comes walking in my room. And I'm like, "What are you here for?" And he looks at me and he says, "Well, I'm here to talk to you." And I said, "Well, you were a pain in the butt. And now that you're graduated and an adult, I can say that." And he said to me, "Yes, I know, and I'm apologizing right now." He goes, "And if it wasn't for you, I wouldn't be doing the job that I am right now." Take a guess on what job he had. It was plumbing. Yep. Did I say the story then before?
Yeah.
Okay. See,
Yeah,
I'll stop it.
Not PVC. I think PVC pipe.
Mm-hmm. Yeah. Yeah. And then he's making good money though. So thank you for telling me I said that. I didn't know. Sometimes I say that story and then sometimes I don't. I think it's a very valuable story because it shows you the power of math, that it can open doors for everybody depending on what job you want to do. Okay, so I'm going to substitute everything into the formula. I'm first going to get the exact answer and then I will use my pi button. I do that because sometimes in standardized tests they leave it in pi form, and I want your mindset to be flexible and be able to do both. Okay? So, 2 pi r is 5, and I'm going to put squared, plus pi times 10 times 11. Now, many of you think, "Oh, I'm just going to write everything down, whatever, and just do half of it in my head." And those are the students that end up either using the wrong formulas or doing their math incorrectly. And I can't give partial credit because you didn't show me anything. The ones who do well on tests and usually get the hundreds are the ones that actually write it out, just like I do. So what's 5 squared times 2? That'd be 50 pi plus 110 pi, which would be 160 pi miles squared because it's area, right? Now, if I want the approximate answer, I would actually now use my pi button or 3.14, but you have to figure out, a lot of times it will state what you need to use. I think CUDA software uses the pi button. So it's 160 a second. Pi is 502.7. Oh no, it's at hundredths, so 6.5. So 502.65 miles squared, because it said hundredths place. Okay, so what's the formula when you have one of these, which is a rectangular prism? Anybody remember that formula? 2 length times width plus 2 length times height plus 2 width times height, right? It's just all the different combinations. That's how I remember it. Okay, so length, width, and height. And it's kind of skewed here, so I would say length, the 5 would be my width, the 4 would be my height, but it really doesn't matter as long as you're listing 5, 5, and 4, right? Okay, so I'm going to do 2 times 5 times 5 plus 2 times 5. Oh, why did I put that? 5 times 4 plus 2 times 5 times 4. And I get, the first one is what, 50, and then 40 and 40. First now I'm hot. I was cold and now I'm hot. Okay, 50 plus 40 plus 40 would be 50 plus 80, which is 130 km squared. Anybody confused on that one? We're gonna get these all right when we do have a test next week. Okay, now we have a cone. I don't remember the cone one off the top of my head. I know it's gonna be 2. I know, for some reason I know it's gonna be pi r squared. Pi r squared plus pi r, and S is actually L for that. I use L, that it's this height here that's slanted. So, or S for side. So it would be, thank you, by the way. It'd be pi times 8 squared plus pi times 8 times 17.9. So this would be 64 pi plus 8, 8 times 1, or 17.9, 143.2 pi. So I add those together, and I get 207.2 pi meters squared. But if I want the hundredth, now I'll multiply this by pi, and I get 650.94 meters squared. Any questions on that one? No? Oh, we had 2 cylinders. I don't know why I put 2 cylinders on there. Snuck in there. So this one would be, again, 2 pi r squared plus pi DH. What is radius? 7. What is diameter if radius is 7? 14. And height is the distance between the two circles, which is also a 7. So this would be 2 pi 7 squared plus pi times 14 times 7. So 49 times 2 is what, 98 pi plus 14 times 7 is, another 98. 98 pi. When I add them together, I get 196 pi, and that would be meters squared because it's surface area, not a 3, a 2. And then if I approximate that by multiplying pi, I get 615.75 meters squared. So y'all can find those pipeline surface areas, figure out how much plastic or whatever is needed for that PVC piping. Okay. And then we need surface area of this one. What kind of shape is this? Well, you have a triangle base, but it's called a pyramid because it's a pyramid because I have an apex. And surface area of the pyramid would be, do you all remember this one? It is 1/2 LP plus area of the base. Right? Okay. So this is an equilateral triangle. And if it's equilateral triangle, P stands for perimeter of the base. So P is going to be 6 times 3, which is 18. L is the slant height, which is the height of the triangle faces, not the height of what I'm sitting on here. So that would be 4.4. And then to find the area of the base, what type of shape is this base? It's a triangle, which is base times height divided by 2. So base would be 6, small b is 6, and then the height of this triangle is 5.2. So it would be 6 times 5.2 divided by 2, which is equal to 6, turn it on, 6 times 5.2 divided by 2 is 15.6. So now I have all the information to put into my formula. I'm not done yet. So surface area is equal to 1/2. I'm going to use 0.5 to put in my calculator, times 4.4 times perimeter, which is 18, plus 15.6, which then gives me 0.5 times 4.4 times 18 plus 15.6. And I get 55.2 yards squared would be the surface area. Right? Yay or nay?
Yay.
I don't know how come I got another. I did that twice. I got 2 cones and I got 2 pyramids. But this time, hopefully, I'll know the surface area. Pi r squared plus pi. What was it? Why do I not remember pi RL?
Do you confuse it with like the volume?
No, it's just I don't know. I don't. I know the volume of it is 1/3 pi r squared h. It's just surface area. I always forget. So R is equal to what? The diameter is 4. So what's R? 2. L is 10.2 or S, depending on how you're looking at it on your notes. So it's going to be pi times 2 squared plus pi times 2 times 10. I don't know if I'm going to squeeze a point 2, which is, I'm going to give you both the exact and the, so 2 squared is 4, so this would be 4 pi. And then the other one would be plus 20.4 pi. And when you add that together, that's 24.4 pi inches squared, which is approximately 24.4 second pi is 76.65. 76.65 inches squared. So now we know how much cardboard we would need. Well, if we subtracted this off, this would just give you the cardboard of a party hat, this part here. Okay, and 2 more surface area, and then we're switching to volume. Again, this is a rectangular prism, so 2 LW plus 2 LH plus 2 WH. We have length as 11, width as 3, height as 7. And if you would have these out of order, it wouldn't make a difference, just as long as you're only using these numbers once each, right? So this would be 2 times 11 times 3 plus 2 times 11 times 7 plus 2 times 3 times 7. So this would be 33 times 2 is 66. 77 times 2, I think, is 144, but I'm going to double check that. No, 154. Good thing I checked it. Plus 154. And this is 21 times 2 is 42. And then I just add all those together. So 154 plus 66 plus, oh, 42. And that gives me a total surface area of 262 meters squared. Okay, so this is a pyramid. What's the formula for the surface area of a pyramid? 1/2 PL or LP plus area of the base, where perimeter is the perimeter of the base, and that is 1 times 4, which is just 4. L is your slant height of the face of the triangle, so that's 2.1. And base is the area of the base. It's a square, so that's side squared, which is equal to 1 squared, which is just 1. So it's going to be 0.5 times 4 times 2.1 plus 1. So that would be 2 times 2.1 would be 4.2 plus 1 is 5.2 miles right? Any questions on that one? We're all good with surface area? Area of the base is a square with side length 1. So it's side squared, so it's just 1 times 1, which is 1. I like that one because I didn't have to use a calculator. Okay, we good with that one? Okay. Now, volume of prisms are all the same for all the prisms. Volume equals area of the base times the height. Volume formulas are a little bit easier than surface area formulas. Because if I was doing this surface area, I'd have to find the surface area of the two hexagons, and then the area of all these rectangles, and then add them together. But now this one, all I have to do is capital B, but I have to remember, how do I find the area of a regular polygon? And that would be the 1/2 times apothem times perimeter, where the apothem on this one is 10.4, and my perimeter would be the side length of 12 times 6, because is 72. So the area of the base is equal to 0.5 times 10.4 times 72, which 0.5, yep, 374.4. And what's the height? The height is the distance between the two parallel bases. So the height is equal to 6. So now I can find volume. Volume is going to be 374.4 times 6, which is 2246.4. And now it's volume. What changes for this exponent? What should this exponent be? Cubed, which is a 3. Yep, because it's volume. What shape is this? It's a pyramid, right? So that is going to be 1/3 area of the base times the height. What is the base? The base, no. What is the base? The base is a triangle, and it's area of that base, so it has to be base times height divided by 2. And the base and height of a right triangle are the legs. So this is going to be 6 and 8. So 6 times 8 divided by 2, which would equal 24. Height then is the height from the apex perpendicular to the center of the triangle, and that is 12. So 1/3 times 24 times 12. If you don't want to put 1/3 in your calculator, you could do 24 times 12 and divide it by 3, right? So 24 times 12 divided by 3 gives me 96 feet cubed. Biak's my new friend, by the way. Right, Biak? We're friends now? We are friends. Okay. So volume of these are easy. You could still use volume equals capital BH, or elementary school students use volume equals length times width times height. because length times width is area of the base, right? So length is, you could call what, 12, no, 4, 12, and 6 are 3. So 4, 12, and 6. And it doesn't matter which order you have these in. If you put 12 here and 4 here and 6 here, you'll still get the same answer because I'm just multiplying all 3 together. So 4 times 12 times 6 is equal to volume. And that is 288 kilometers cubed. We can do one more. This is the same way, same formulas. So volume would equal 7 times 9 times 5. 7 times 9 times 5, which volume equals 315 meters cubed. Dun, dun, dun. Why did I put so many on here? We already did one of these. For time's sake, I'm going to skip number 13. If you want the answer for it, I'll give it to you afterwards if you already did it. 14, though, is a new one. It's still a prism, so its volume equals base, the area of the base times the height. Remember, height is the distance between the two parallel bases, which in this case is a hexagon. So I need capital B is going to be 0.5 times apothem times perimeter. So 0.5, what's my apothem? 5.2. And then because this is your apothem here, perimeter would be the side length times the number of sides. How many sides do I have? 1, 2, 3, 4, 5, 6. So 6 times 6, which is 36. So go ahead and calculate that out. 0.5 times 5.2 times 36 is, this is 93.6, and now I'm going to multiply it by the height. So it's 93.6 times height is equal to 12. 12 is the distance between those two hexagons. So 93.6 times 12 is 1,123.2 meters cubed. And if we already did a square pyramid, I'll do this one. And then I think we have two. Do we have two word problems? Yes, word problems. Yay! Okay. So, volume equals 1/3 capital BH, right? So, again, your base is another hexagon. So it's going, I don't know why I put B, it should be a B. B is going to equal 0.5 times your apothem, which is 5.2, times perimeter. Perimeter's side length is 6 again. So what's 6 times 6? 36. And then height is 11. So area of the base would be this, and then I'll plug everything in. 0.5 times 5.2 times 36 is 93.6. So volume is equal to 1/3 times 93.6 times 11, which is equal to 343.2 centimeters cubed. Okay, let's look at the word problems. A company is deciding which box to use for their merchandise. The first box, and when we're thinking about boxes, we're going to think about them as a regular box, like a tissue box, a rectangular prism. The first box measures 8 inches by 6.2 inches by 10.5 inches. The second box measures 9 inches by 5.5 inches by 11.75 inches. Which box requires more material to make? So let's figure out box A and box B surface area. Box, and hopefully you all knew to use surface area, right? Box A would be 2 times LW plus 2 times LH plus 2 times with H. Okay, so here the first box measures, I'll call this length, width, and the first box measures. Where's the 8? The first box measures. Oh, yeah. Okay, so length, width, height. Sorry, I missed that one. So that's what I'm going to label them. So length, width, height, just in order there. So 2 times 8 times 6.25 plus 2 times 8 times 10.5 plus 2 times 8, no 8, 6.25 and 10.5. And so I'm going to use my calculator. So 2 times 8 times 6.25 plus 2 times 8 times 10.5 plus 2 times 6.25 times 10.5. I'm going to relook at that, make sure I did it right. 2, 8.6, and a plus, and that, and now I'm going to press enter. Did everyone else get 399.25? Okay, so this is the surface area of box A. Surface area is equal to 399.25. 399.25. Now I'm going to do box B. Box B, length, width, height would be 2 times 9 times 5.5 plus 2 times 9 times 11. Yeah, 11.75 plus 2 times 5.5 times 11.75. Yeah, I know. And then we got to figure out cost. So 2 times 9 times 5.5 plus 2 times 9 times 11.75 plus 2 times 5.5 times 11.75. and I get a total of 439.75. And the question asks, which box required more material to make? So box B, or the second box, right? Or second box. Now, it said if each box from 5, because I copied this off of something from the internet, so it meant from this one. I should have deleted this, cross that out. If each box used material that costs 0.03, so 3 pennies per square inch to make, how much does a company save by choosing to make 50 boxes of the smaller box in comparison to 50 boxes of the larger box? So, what's the difference between the two surface areas? 439 minus 70 or 0.75 minus 399.25 is how much? Go ahead and give me that answer. What is it? 40.5? And then if I multiply this by 0.03 times 50, that would tell you the savings of using the smaller box. So 40.5 times 3 pennies times 50, how much money do they save? Yeah, $60.75. Do you think $60.75 is worth doing the math? To make sure? Yeah. And if it was a larger company, it could be thousands of boxes. I mean, it really, so that 3 pennies adds up.
We can look and do this on company's balance sheet.
Mm-hmm. Okay, and then we have another word problem, except this A shouldn't have been there. Cross it out. The pedestal on which a statue is raised is a rectangular concrete solid, so like a rectangular prism, measuring 9 feet long, 9 feet wide, and a half a foot high. How much is the cost of the concrete of the pedestal or in the pedestal if concrete costs $70? Look very carefully though, per what? Per cubic yard. What do I have to do before I start doing the problem? I don't want to do volume first because the measurements in feet, what's the cost in? You got to change your feet to yards. You have to do your conversions first, right? So here, one yard is equal to 3 feet. So I'm going to divide each of these units by 3 to figure out the cost. So what's 9 divided by 3? 3. So it's going to be 3 yards by 3 yards. What's 0.5 divided by 3? That's a half, so that'd be like 1/6. What is 0.5 divided by 3? Yeah, it goes like 0.1666666, right? So we'll round that to 1.17. Is that fair? Okay, multiply this out to find the cubic yards. So take 3 times 3 times 0.17. Tell me what that answer is. What is it? 1.53, and that'd be cubic yards. So that's how much cubic yards I need. You know, you guys pass the guys that They're rolling the concrete. Have you ever seen those trucks that the thing is rolling? It's actually making concrete. My husband's been to concrete plants before. He says it's really interesting.
My mom used to tell me when I was a kid they were making ice cream.
What?
My mom used to tell me they're making ice cream. That's what I was kid. They're like, yeah, they're making ice cream.
No, they're making concrete. Okay, so but what would the cost be? What would I multiply? I would multiply this by $70. So how much is the cost? What is it? $107.10. Okay. I just want you to see how surface area and volume are actually used in real life. A lot of pouring concrete, that's all volume. Mulch is volume. When you buy mulch, that's a volume because you have length, width, and then the depth, how much you're pouring in. Playgrounds. If you think about like nowadays, they're using shredded tire stuff to put there. That's another volume because it's length, width, and the depth. Okay, today's work. We are leaving surface area and volume. By surface area, well, not technically by because we will see it again on our test. But today we are going into circles. Use.
Oh, why is it bad?
It can get tricky. You have to know what you're doing.
Well, I usually don't know what I'm doing, so.
Did you already finish?
Yeah.
I'm turning with you now. That's for you to keep. That's review.
Well, for yesterday.
Oh, yeah. I'm turning yesterday's work. It's for you to review so that way you know. It's no surprise what you see on the test. Do I tend to surprise you on tests?
Yes.
I do?
Sometimes.
Don't sound clueless. You know what you're
No,
doing.
I don't surprise you on tests. I tell you what's on your test. And we do notes every day to prepare you for the test. I do not make things big surprises because I don't believe in that. I believe in everybody knowing what they are required to know so that way they can study and do well. I don't want that. Let's see. Maybe I'll just try doing it on the circle notes. I don't know. I'm going to just try doing it on the notes. Not this. What is the circle notes? I'm going to try writing on these and see if this is better. Okay. A lot of this is review because we actually been using circles, right? We couldn't do cylinders without circles. We couldn't talk about rotational symmetry without circles, right? But now we're going to get into a lot about circles. So, a circle is a set of points on a plan. That should say plane. Plane. Put an E there. That are equidistant from a given point to the center. So here's your center, right? And when you spin a compass, that compass is opened up to a radius. And every single point on this circle, on the edge, to the center has that same distance, and that distance is called the radius, right? So, by just the definition, we know that all radii of a circle are congruent. And how many different radii are in a circle? Infinite. I just can keep drawing and drawing and drawing. Depending how skinny your pencil is, you can just keep drawing and drawing radii, right? Think about spokes on a bike. Every single spoke on a bike is a radius going from the center to that edge of that metal piece, the rim. Okay, good? Any questions on that? Okay. If it says here, if MZ is 4 units, what other segment, boy, I'm horrible. What other segments are also 4 units long if M is the center of the circle?
MW.
So MW would be 4. Oh, let me try. So we have MZ is equal to 4, right? And then we're saying MW as also equal to, and then MX, any others? MY. These are also all 4. So this is 4, 4, 4, and 4. Is ZY 4? No, that's called a chord. We're going to get more into chords later. And it's not a musical chord, but it's spelled the same way. Okay, let's see here. Label all the lengths that are 3 units long due to being a radius. So go ahead and do that again. I'm going to give you a chance, and then everyone at your tables, make sure you check each other's work, okay? And talk with your neighbor, see if you decided how many are the same. I want everybody to talk with each other, make sure they have the same answers. Hmm?
Oh.
So we have how many? How many did you get? 4? 4 or 5? Uh-oh, go talk to the people at your table, because I see 2 said 4, 1 said 5. So verify. Let's see what the issue is. Okay, AB, I agree, and then is equal to AC, which is also equal to A what? AD, which is also equal to AE. Yeah, and they are all equal to 3 units, right? So this one, this one, this one, and this one. They all, oh, we couldn't use AG. They tried to trick you. Why couldn't I use AG? It didn't go all the way to the end of the circle. Okay, are we all in agreement now? Okay, good. Okay, a chord, spelled CHORD, is a segment whose endpoints are on the circumference of the circle. A diameter is actually a special chord that contains the center of the circle. And I'm going to write one more thing on here that you should write. It's also the longest It's the longest chord. So a diameter goes through the center of the circle and it's considered the longest chord. And guess what about diameters? All diameters are congruent. They're the same measure, right? So it says name all the diameters. We're going to assume our centers right here. What diameters do we have? We have RS, QP, and BA, and YX. Do we have S? Oh, SR and RS is the same, right? So we should have 1, 2, 3, 4. We have 4. Did I list 4? Good. I'm good. Okay. Now here, ooh, that's hard to see. I wonder if I can. Where's view? View. I still can't see it. I have bad eyes. Let's make this. I see it a little bit better. Up there. It's a little bit better. Okay, the center of a circle is point A. The diameters have a length of 10 units. Which segments are diameters? Label their lengths. So it says here, which ones are centers? DE, DE, because it goes, here's the center, so it has to pass through the center. So DE and CB. And what length are they? They're 10 units. Is FG 10? No, because that's a chord. It did not go through the center, so it is not a diameter. Right? Any questions? DE goes through the center of the circle. That is an E, right? And then CB also goes through the center of the circle. It didn't look like a straight line. I think it was meant to be a straight line. That could have been me when I put that in there. But I think it's supposed to be a straight line. Yeah, it's supposed to be. Sorry, but you are correct. It kind of looked a little bent, but it isn't. Okay. A line that intersects a circle in 2 points is called a secant. Can you all say secant? Secant. So a secant intersects a circle at how many places? 2 points, because it intersects.
Wait, what's the difference between a secant and a chord?
Because it passes through.
I'll pass it through.
Yeah. So a secant passes through while a chord's endpoints are on the circle. Okay. Now a tangent. We talked about tangent, but this one's a different tangent. This is a tangent to a circle. And when you get into calculus, you'll learn why they are the same, why they're considered the same name. Okay? Who here is planning on taking calculus? Who here has taken calculus? Israel, have you ever taken calculus? Different, like finding derivatives? No. Calculus would be, if you look at my clock, number 3, where the 3 is, that's calculus. That's real basic calculus. Calculus is, okay. May will end up taking calculus. Anybody here going to get a business degree? Business degrees they take an applied calculus. It's called business calculus, where I took theory calculus. Three three semesters of theory calculus. Okay. But anyway, a tangent line intersects a circle exactly at one point, and we call that point the point of tangency. So it hits it just at one point. And some of you made those. Remember when we circumscribed or inscribed a circle on the inside of a triangle? And the goal was to touch the triangle only at one point on each side. So some of you have already done this. Okay, and that's called the point of tangency. As the point where it intersects the circle, the line is called the tangent line. Any questions on that? No. Okay, so here's a picture. Just because a picture means 1,000 words, isn't that the saying? We have a chord, we have a radius, we have a diameter, we have a tangent line, we have a secant line. Do y'all have that one? Okay. Hope so, because I just pulled up the notes to see if this is easier to go through. Okay, so now let's look over here. Tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, tangent of a circle. So go ahead and talk with one another right now and figure out from the picture here, am I going to call AC chord, radius, diameter, secant, or tangent? So go ahead and work with each other at the table to look over your vocabulary.
AG is a chord.
Talk to one another.
D is tangent.
Now D shows a line. Do you see that there's a line over AG? Be careful.
AC, right? Oh, radius.
And a diameter is considered what? Also, it's a diameter
Radius.
and a chord. No. Diameter is a special chord.
Chord is AC. Singing goes out.
Okay, so AC, do we have an idea what AC is? Radius. What's DE? Tangent. That's Sinpy when he's laying out in the summer getting a nice tan. He's a tangent, right? No, okay. AB is a, it's also considered what? It's also a chord. Diameter is a special chord that's the longest chord of your circle and goes through the center. And then what's AG? Secant. Secant?
Yeah. I'll say C.
Okay, so here is some vocabulary or some theorems. In a plane, a line is tangent to a circle if and only if the line is perpendicular to the radius of the circle at the end point on the circle. So see here I have a box. It can only be tangent if from the radius I draw a segment and to that point is tangency where it intersects the circle, it makes a right angle. If it's not a right angle, then chances are it's a secant. You may not see it, but it may intersect that circle at two different points. So, because I know right angles, and I know Pythagorean theorem, I can prove or determine whether or not a line or segment is tangent by using the Pythagorean theorem. And you all thought you were done. Probably are like, why would I use Pythagorean theorem when talking about circles? Right? If I would have told you before I handed this out that you would be using Pythagorean theorem with circles, you all been like, huh? But we do. So right here, we are going to check to see if this is a right angle or not. If this is a right angle, then I can say that TS is tangent to this circle P at T. If it is not a right angle, then it is not tangent. To check to see if it's a right angle, since this makes a triangle, we are going to do Pythagorean theorem. A squared plus B squared equals C squared. If it works, then we say yes. If this doesn't work, then we say no. We always use C squared as the largest side. And it should be across from whatever we're thinking to check is the 90-degree angle. So I can mark this as A and this is B, and then I'm going to mark this as C because it's across from what I'm checking to see if it's 90 degrees. So 12 squared plus 35 squared, does that equal 37 squared? 12 squared is 144. What's 35 squared? Probably a big number. 1225. And add those together, and I get 1369. Now, if I take this and square it, and it's 1369, then I say yes. If it is not 1369, then I say what? No. So 37 squared, voila, it does equal 1369. So we would say yes, it is tangent. TS is tangent to circle P.
Do the same thing.
Okay, yep. For the next one, okay. So we do the same thing. However, this is saying it is tangent, but now they want us to find R, right? So I'm going to use Pythagorean theorem. This would be A, this would be B, and this would be C. So R squared plus 80 squared would have to equal, well, what's C? There we go. 50 plus R plus 50 squared. So R squared plus, what's 80 times 80? 6,400, I think. Yep. Now this is algebra 2. Somebody said how much they like algebra 2. This would be, actually this is algebra 1b where I'm going to FOIL this out, right? R plus 50 times R plus 50. R times R is R squared. 50R times 50R, we get two of those, which is 100R plus 2500. If you recall, this would be R times R is R squared plus 50R plus 50R plus, oop, I dropped a zero, plus 2,500. And I just combine those in my head to make 100, right? Okay, now the R squareds cancel out on both sides because if I subtract R squared on both sides, that's zero, right? So now I'll just subtract 2,500. What's 6,400 minus 2,500 is 3,900 has to equal 100R. So what does R equal? 39. So what would, this would be 89 right there when I add those two together. But yeah. Make sense? Doesn't make sense? Mr. Adam and Mr. J would be so happy seeing us having to foil. Okay, so theorem.
You know, it sounds good right now, but yeah, we'll make sure you guys
Okay, turns out that if you have a point outside of a circle and you draw two tangents, these two are going to be equal. Kind of looks like one of those eyeball things if you think about like an optometrist. Do you think optometrists may use this? Because your eyeball is kind of a sphere. Maybe? I don't know. I'm not an optometrist. Okay, so knowing that this is the case, if I have a problem set up like this, RS and RT are both tangent to the same circle, right? How would I find X? Well, if I know they both have to be equal, 3X plus 4 has to equal 28. I subtract 4. 3x is equal to 24. Divide by 3. X is equal to 8. These are one of my favorite type of problems. We'll see if you like these or not. I'll try and blow this up just a little bit more. No, that's about. I think I like the using. I was experimenting, seeing if I like using the notes or my PowerPoints. I think I like using the PowerPoints so you all back there can see a little bit better. But you never know until you try, right? Okay, do you all have this on your paper? Okay. So it wants to find perimeter, but we have missing pieces. We don't know what this length here is, and we don't know what this length over here is. Any ideas on how we could find some missing lengths? And you all are looking at me going, no, you're the teacher. Tell us, right? Okay. If if from here, here's a point, and it says here that lines appear to be tangent are tangent. So from here to here has to equal the same distance, correct? So if from here to here is 13, what's from here to here? 13. Well, if this whole length is 25.4, could I find this missing length right here? 4 minus 13. What is 25.4 minus 13? So this is 12.4 over here, right? Well, if from here to here is 12.4, what's from here to here? 12.4. So I found one of my missing side lengths. If from here to here is 9.6, wouldn't from here to here also be 9.6? So if I subtract, I would find this little piece right here. What's 13.7 minus 9.1? 4 point, was it 4.6? 4 point. Oh, that's a 6. Sorry. Yes. So that should be 4.1, right? And so what's this little piece out here that we were missing? That'd be 4.1. Now to find perimeter, be careful. You don't want to add in pieces that are already measured. Do you see how I wrote stuff on the inside and then I wrote stuff on the outside? I did that for myself to keep track of, oh, I was looking for this. This is part of this, right? The insides are already measured. This is on the outside. 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 So now I add all of the ones that I just circled together, and that would give me perimeter. So now I have to get the sum of all these numbers. So I use my handy dandy calculator. 12.4 plus 25.4 plus 13 plus 4.1 plus 13.7 plus 9.6. And I get a total of 78.2. That would be the perimeter. I added all the ones that I circled. All those outside ones are just telling me the outside lengths. So at your tables, go ahead and do number 2. I'll be walking around to see how well you did. So if you have your answer, raise your hand. I'll check it. Well, check with your tables first. I want all the tables to come to a consensus on what you think the answer is going to be. And then I will do a thumbs up or thumbs down. two came to consensus? Both agree? Okay.
About 12.7 plus
24 is this one. Like
Speed 24.
oh, this one over here is just like that one. This is 11. You subtract 11. That's the ones that are on the screen now. 12.7.
Oh, it is. Okay.
the 25.7 plus 23.7. Now I get it. Okay. I forgot the
So it's 27.
Oh,
It's like once you find the missing links, then you add them together, and then
I'm missing this line, right? Well, from here to here is 12.6.
Oh, yeah.
What's this one? Problem is trying to find this one. Walk around to find this line. This is 11 from here
Oh,
to
okay.
here,
I'm
and
just gonna get like
this
this
would also be
for
11.
more low lights.
So what's 24 minus 11?
Like instead of like bleaching the cap off of it. I
So
usually
this inside is 16. It's all meant, this whole thing is.
No, it's not gonna be much of a
Wouldn't
change.
add
The only difference is like
This
this
is the
one part. I
outside.
do like it fun, but like I don't like keep touching up this
If
area.
this
'Cause
is
it's just gonna
13,
like
though,
fire
this is
off.
also
Like,
16.
so I'm trying to like move this
So
one.
all the ones that
I just like
circle are the outside pieces, so add all those together.
Now you gotta compromise.
No.
My hair used to be so long too. Like I used to have
Okay.
really long hair.
So,
I've been pushing it
you
since
go ahead and write.
so my hair has definitely changed. It's not that anymore.
So this is 11, this is 11, this is 13. Part of this 24.
I like the light.
Add those
It,
again.
it looks good. It's like
This is
dimension, you know, like it's not just one flower.
This is 12.7. 11.
It's like the lighter your hair is.
Oh, yeah, it is.
And it's like, and then it's like also what's shiny.
That's why I write
It's,
the side is like,
It's 345.
so you would add this one. That's part of it.
and like, I don't know what it is, but I like dimension in like hair. I don't like, I feel like I get character. Like, instead of just like,
Okay, you want to explain, I'm going to. You got your number.
it's kind of like, it's so weird, because like, it's not even all darker, because usually.
Well, and she could probably explain it in your own language, which would be probably more beneficial.
So it's like, it's already gonna look
I would
brighter.
And if she doesn't do what we have, tell me, and I'll be over there and help you. Can you explain it to her?
I'm just trying to get. You know
But you know what I mean?
what I mean? Because I'm not gonna keep touching this up. And this is not too bright at all. He like it's already like thrown out. So. Like people's hair like. They usually like I have to really take care of it.
Yeah,
Like, in order for it to like
Okay.
And you don't even know.
So,
I don't know. I like this lesson. I know every time you say that, I'm like, it just gets smarter. But I think I should leave it like. It's
try adding those up.
no, it's not. It's 301.
This is 11.
Yeah, so it's but it's like I don't know. It's no way it's healthier looking. Yeah.
Got it?
I know.
What about May? Do you like these? I like it. It's just like a puzzle. Did you all get 73.4?
Yes. Yeah. Well, yeah. We rounded it up.
Well,
It is okay.
because it's an exact answer, right?
Exactly.
Okay.
Oh yeah.
Did you get these answers? Did you get 73.4? Very nicely done. Israel, did you get 73.4? Did you get 73.4? Did she explain it? Did she do a good job? Good job? Okay, good job. Are we all good here? Okay. So, we all good, right? Somebody's not very happy. Uh-oh, what happened to my pen? I got up to walk away and then I lost my pen. Did it fall? Ah, there it is. Ugh. Okay. So, I almost fell. Jeez. Okay. So, for those who are watching this at home, from here to here is 12.7. So, from here to here has to be 12.7. I'm missing this length here. I'm gonna have to walk around because I can find this length with these two lengths would be equal, right? So if this is 11, that means this is 11. 24 minus 11 means this is 13, right? Which means this missing piece out here is also 13. You add these pieces on the outside because it's perimeter together, and that gives you 73.4. We good? Okay, now there's other theorems about chords and radii. If one chord is perpendicular bisector of another chord, then the first chord is a diameter. Or it could be a partial segment, but it's coming from the center. Okay? So if one diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. What does that word bisect mean again? Do we know what bisect means? You said it, Israel. Can you say it one more time?
Cut it off.
To cut in half, right? So if becomes a perpendicular bisector, so these two pieces will be equal, and the measure of these two arcs would also be equal. So if I see that this is 90 degrees and it's coming off of a diameter, I know this is a diameter because it's marking E as the center of the circle, right? What's the length from F to C if AF is 7? 7. So then the whole length is what? Yes, 7 plus 7 is equal to 14. So AC is equal to 14. FC had to be equal to AF because if this is perpendicular, it actually is and this is a diameter, this is actually a perpendicular bisector. It cuts this segment, this chord, in half. Okay? So, and how it affects the arc measures. If this is a perpendicular bisector of this chord, which is coming off the diameter, so it has to be, these two are going to be equal, but also the arcs they intersect will also be equal, right? So how would I find, what are they asking for? How would I find the measure of the arcs? Find the measure of the arc in the given diagram. CD, DE, and then CE. So I'm going to do 9x has to equal 80 minus x. I'm going to solve for x. I get 10x is equal to 80. So x, divide by 10. Why did I do that? Divide by 10. X is equal to 8. So CD would be 9 times 8. What's 9 times 8? 72. And when you're talking about arc measures, they're talking about it in degrees. What about DE? It should be the same because we said they were equal. And then what would the whole arc be? What would be from here to here if each of these are 72 degrees? Yeah, you just add them together and multiply by 2, which would equal, what is it? Yep, 144 degrees. I promise I'll give you a break. How much more do we do? Do you want to take a break now, and when we come back, we'll do some more of these practices? Okay, I probably am not, I'll go over some of those practices. Okay, go ahead and take a 10-minute break. We'll finish the notes, and then I'll hand out your independent practice. So take a 10-minute break, and then come back. Okay, so here it says in the diagram, suppose ST is equal to 32 and CU is 12 and CV is 12. Find the given length. QR. Well, if this is perpendicular and it's coming off of a radius, that means it cuts this in half, right? So if from Q to U is 16, what would QR be? 32. Also, because these two are the same distance, turns out that if these segments here that are perpendicular are the same distance, these chords are going to be equal because it's a circle and everything's equal as you're going around when you're the same distance away from the center. You are, which you are going to be. Yeah, so if QU is 16, UR is also 16. Now, which of these segments is considered a radius when you're looking at the picture? Yes, this here is a radius. And if this is 90 degrees and makes a straight line, this has to be 90 degrees also because it makes a straight line. 90 plus 90 is 180. What I have a right triangle here. How do you find the missing side of a right triangle? You use your Pythagorean theorem formula. A and B would be your 16 and 12. This would be A, this would be B. Across from the 90 degree would be C, and that's what QC is. So 16 squared plus 12 squared has to equal C squared. So I would use my handy dandy calculator. 16 squared is 256. 12 squared is 144. I add those together. I get 400. What is the square root of 400? 20. So this would be 20. So all the radii of circle C would be 20 units, whatever the unit is, since they didn't give it to us. Right? Make sense or doesn't make sense? Okay. So right here, this is what your homework's gonna look like. Okay. Now, if you get confused about what X is referring to, you could always ask me. But X as a diameter would be where close to where that center is. This is how CUDA does it. I don't think CUDA does a great job on differentiating between diameter and radius when they're marking the X. In CUDA, if they were going to mark a radius, it would be like this, not where the center is. Does that make sense or not? Okay, so here X is the diameter. Here X is this chord right here, right? Do I have to actually do a whole lot of work to get this answer? No. What is X equal to? It's just 18. Because this is 90 degrees, these two pieces have to be equal. So I didn't have to do any work for that one. Now, how would I find the diameter? Well, if from here to here is 5.2, and from here to here is 5.2, isn't this a radius? The whole thing? Look at it close. Here's the center, the endpoint's over here. The whole piece is a radius. So how long is this radius? 10.4 is equal to radius. How do I find diameter then? Yeah, just multiply it by 2. So that'd be 20.8 is diameter. And that would be your answer. Sad baby. Let's try some other ones. Are we good? Are you still writing? I can wait. It gives me a chance to drink my cup of coffee here. I should be drinking water instead of coffee. I love my coffee. It's my vice. Okay, can I move on now? Okay, so now I'm here, and guess what? This is the same thing, isn't it? What's 11.1 plus 11.1? 22.2. So radius is 22.2. So diameter would just be double that, which would be 0.4. Yep, that'd be my answer. Okay, so now here they put X, and I highlighted it so you can see which side they're talking. They're talking about this length right here. Well, I do know this is 9.3, but that's not the length they're talking about. I also know all radii of a circle is 12.1, right? So I could go like this and put 12.1 like this. What do you see here? All right, triangle. So I could find this length, and you're probably like, well, how does that help me find this length? Well, this whole thing is a radius. I know this whole length has to be another 12.1, right? So once I find this piece here, I subtract 12.1, and it's going to give me this missing piece. So this is a multi-step problem where I have to find this missing piece from here to here using Pythagorean theorem, and then I'm going to subtract it from 12.1, and that'll give me this tiny piece up here. So I'll call this A squared plus 9.3 squared has to equal 12.1 squared. So A squared plus, what's 9.3 squared? 86.49, and 12.1 squared is 146.41. We subtract, we get A squared is equal to 59.92. What's the final thing we always do with Pythagorean theorem? We have to take the square root. And that was approximately 7.74, right? And so I'm going to subtract 12.1 minus 7.74. And this would be what x equals. Because A is from here to here. Radius is 12.1. You subtract 12.1 minus 7.74. And I get 4.66. So that was a multi-step problem of these. Oh, I put 12.1. I'm sorry. I fat fingered my calculator. Yeah, that'd be 4.36. Because I don't know why I put 4 instead of 1. Because they're right above each other. It happens. That's why we all do it, right? We verify each other. Is a good thing. Okay. Can I go to the next one? And I'm just looking. Okay, so we have. I'm only going to do one of each of these, and then because I want you to have time to do your homework. Okay, so if this is tangent, that means this makes a right angle, right? So I can find this whole length, and this whole length would be C, correct? Now, but it just wanted this piece from here to here. I'll show you how to find that after we find C, because I don't want to overwhelm you. So this is A and this is B. So 8 squared plus 15 squared has to equal C squared. 64 plus 225 has to equal C squared. What is that? 289? 289 has to equal C squared. I'm going to take the square root. What is the square root of 289? I think it's 17. I was going to say, I think it's 17. C is equal to 17. But 17 wasn't what they were looking for. They want this length right here. But I know what this length is. What is this length? That's 8, because it's another radius, right? If this whole thing has to be 17, and from here to here is 8, what's this length from here to here? 9. That has to be 9, because 9 plus 8 is 17. So X, or your question mark, would actually equal 9. You use Pythagorean theorem, find the whole length, subtract off the radius, and that'll give you this missing piece here. I am going to skip number 6 because that's just another Pythagorean theorem. I'm going to just do one of these. We did it earlier, but I just wanted you to practice before moving on. I just wanted to do another one. Plus, I like these. Okay. We have a couple missing segments here. We have this piece that's missing, right? We have this piece that's missing, and we have this piece that's missing. Do we have any other ones? Oop, I'll roll up. Why don't you let me roll up? Scroll up. Okay. So I know this piece, I don't have to do any work. What is this length from here to here? 12. We stated in the theorem that if I have lines that are tangent from a point outside the circle, that to the point of tangency, these two have to be equal. And that would be the same for this one. So what would I write right here? 4.1. This one is the problem though, because I have this whole length. I don't have just this piece here. But if I find this piece, then I would know what this length is, right? If from here to here is 10.5, what's from here to here? 10.5. I subtract to find this length. What is 18.3 minus 10.5? 7.8. So then what's this piece here? 7.8. And be careful, you're not going to add this 7.8 because it's already included in this 18.3. You only add that one. And I'm going to add this one, and this, and this, and this, and this to get perimeter. So you would add all the ones that are circled to get perimeter. So 18.3 plus 5 plus 4.1 plus an, oop, I did it again. I put a 4 instead of, plus 4.1 plus 12 plus 7.8. I'm going to check so I don't put the wrong answer. 18.3, 10.5, 4.1, 4.1, 12, 12, 7.8. Okay, what did you all get? That's what I got too. And units, so they didn't give us a unit, so I'm just going to put a U for units. Okay, we good? I'm not going to do 8, and you don't have to worry about it unless you really want to, because I want to give you time to finish your work. Sheet for today,